Ladies and gentlemen, boys and girls, welcome to another edition of Fun with Molecules. That's right, today we're going to be building more molecules, but not just any molecules, these molecules right here. Now the good news is you're already familiar with them. If you look at the collection number 1, it says 2CO2. Now, do you recognize any of that? That's right, folks. Today we're going to be talking about carbon dioxide times 2. That's all that means. It means I have 2 carbon dioxide molecules. So let's go ahead and find the ingredients right here. So I need myself a carbon, and I need myself another carbon because 2 times C means I need 2 C's. And then I do 2 times 2 for the oxygens, and that means I need 4, count them, 4 oxygens. So I'm going to set this up as 2 separate molecules because that's what we're doing, 2 carbon dioxide molecules. There's 1, and there's 2, and there's 3, and there's 4 oxygen atoms in total, creating 2 carbon dioxide molecules for a grand total of correct. And now we're moving on down to the next thing. It would appear we have 2 of what? 2 of what do you think? 2O2? That's right. It's 2 oxygen molecules. So, let's see. I need to put some oxygen back in the bucket here, or whatever you call this, and then throw it out there. So it's 2 times 2 is 4, which means I'm going to have 4 oxygen atoms. Did I say atoms, molecules? I don't know. I'm going to have 4 of these atoms total. We know that oxygen by itself is not sufficient. In order to make oxygen, we have to add 2 oxygen atoms to create molecular oxygen. There's 1. And you'll notice this says 1O2. This means 1 oxygen molecule. But we need 2. So I'm going to take this oxygen right here, this oxygen right there, combine them together to create another oxygen molecule for the 2O2. 2 oxygen molecules. And now we move down to 4H2. Well, I know that H2 all by itself is molecular hydrogen, but 4H2 is 4 times that. So if in one molecular hydrogen I only have 2 hydrogen atoms, if I multiply that by 4, that means I'm going to have a grand total of 8 hydrogen atoms in 4H2. So let's go ahead and put it together. So what we have here is we got 1 hydrogen atom, 2 hydrogen atoms, creates molecular hydrogen. Now I got to do this 4 times. So I'm going to take 1, 2, boom, another molecular hydrogen, another molecular hydrogen, and another one, boom, for a grand total of 4 molecular hydrogen molecule things. And you'll notice that there are, in fact, 8 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. As noted here, 4 times 2 is 8. Let's see if we're correct. 1 molecular hydrogen, 2 molecular hydrogens, 3 molecular hydrogens, and 4 molecular hydrogens. Yay, we're correct. Happy dance. And now we make our way down the collection number 1 to 2NH3. Now, what does the 2 tell us? It means 2 times N, which means I have 2 nitrogen atoms. 1, 2. And it means 2 times H3. Well, 2 times 3 is 6, which means I have 6 hydrogen atoms. Oh no. Do you know what I forgot to do? I need to reset the atoms. Whew, my bad. So we have 2 nitrogen atoms, and now I'm going to have 6 hydrogen atoms in total, 3 on each of them. 1, 2, 3 creates ammonia, and 1, 2, 3 creates another ammonia molecule thing. And that completes this thing right here because it means I need 2 ammonias. Well, there's 1 ammonia, and there's 2 ammonia, and we have completed the collection in this PhET simulation. Anyways, I do hope that was helpful. My head hurts. Have a good night.